Afternoon, it's Mr. Rashes. Today I want to present a certain concept under trigonometry, specifically under reduction formula. Okay, normally when we talk about reduction formula, we want to find out how do we reduce a certain trig expression to a single trigonometric ratio. Okay, so we want to have a look at a certain expression. It reads cos squared 180 degrees plus x, then plus cos of negative x, then tan x, then cos 90 degrees plus x. We want to reduce this to a single trig ratio. Okay, so the most important thing when dealing with trigonometric expression is to be able to identify the quadrants. When we say 180 plus, which quadrant are we referring to? So I'm going to present this one briefly. This is 360 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees. So in this quadrant, this one is 360 degrees plus theta or plus x. This one is 180 degrees minus theta. Let me just use x minus x. This one plus x. This is 180 degrees plus x. This is 360 degrees minus x. Okay, another thing, very important concept, is for your ability to identify the sign of a trig in different quadrants. Let me present another one briefly again. In this quadrant, according to this is called a cast diagram. In this quadrant, all are positive. We are referring to cos, tan, and sine. They are all positive. In this quadrant, it's only sine that is positive, and the rest are negative. I am referring to tan and cos. They are all negative here. In this quadrant, it's only tan that is positive, then the rest are negative. In this quadrant, it's only cos that is positive. Okay, so now we want to simplify this one in vectors. Let me start with cos squared 180 degrees plus x. Okay, this is the third quadrant, because we are saying 180 plus x. Here is the quadrant that we are referring to. So if you are to present this one, simplifying it will give us cos 180 degrees plus x multiplied by cos 180 degrees plus x. I understand most of you know that if you are squaring something, it means we can expand it as writing the same thing twice. Now, in the third quadrant, cos is negative, because we noted that in the third quadrant, it's only tan that is what? Positive. So we are dealing with a negative cos x here, multiplied by another negative cos x. Then negative times negative, other is positive. Then cos times cos, we are getting cos squared x. So at the end, we are getting cos squared x, because plus cos squared x and cos squared x is just one and the same thing. Now, we are now proceeding to the second expression, which is given by cos of negative x. Okay. Cos of negative x, the cos of a negative angle is equal to the cos of a positive angle. We can prove this by saying cos of negative 60 degrees it must give us the same answer if we are to press on our calculator. Cos of 60 degrees. This one will give us 1 over 2. Same applies to this. It must also give us what? 1 over 2. Therefore, cos of negative x is as good as cos of what? X. Then, moving on to tan of x. Tan of x will be the same as, this is just a limit, is sine x over cos x. So, instead of writing tan x, we can just replace tan x with sine x over cos x. Moving on to the last, which is cos 90 degrees plus x. Okay, this one, if we are to go back to, let me start by writing the simplification here. The answer is just negative sine x. Now, we don't want to memorize, we just have to derive or we just have to find it. How do we arrive at such an expression? How do we arrive at such a conclusion? So, from the expansion of compound errors, cos of A plus B increase cos A cos B minus sine A sine B. Therefore, cos of 90 degrees plus x is as good as cos 90 degrees cos x minus sine 90 degrees sine x. Okay, this one will be reduced to only negative sine x. Reason being, the cosine of 90 is 0. Then 0 times cos x, obviously it will give us 0. Minus sine of 90 is 1. Then 1 times sine x is as good as, okay, this is a negative, so it means 0 minus sine x, which is just negative sine x. Okay, now we have simplified it in batches. We can now just combine our answer to find out our final solution. So I'm sure you can allow me to erase here. I'm sure the presentation is clear. Let me be allowed to erase this part. Okay. Now, under cos squared of 180 plus x, we reduce this one to be cos squared x. Then plus this one, we reduce it to cos x. Then there is a multiplication there. It means we are remaining with sine x over cos x. Again, a multiplication. The cosine of 90 plus x, it has been reduced to negative sine x. I advise learners to put some brackets here to avoid unnecessary mistakes. Okay. Then we have cos squared x plus, we can actually divide this cos and this cos. We can actually divide that. There's nothing wrong. So it means if you have to do that, we are going to remain with sine x times negative sine x. So this one will give us negative sine squared x. At the end, let me increase my space here. At the end, I'm going to remain with cos squared x minus sine squared x. Okay, I'm not yet done. Cos squared x minus sine squared x. Let me just equate it to cos 2x. That's our final answer. But I want to show now where are we getting this cos 2x from. Okay, if you are to write cos 2x here, cos 2x can be written as cos of x plus x. Then, expanding double angle for cos, we are getting cos x. Because this is a plus, it means we must change it from a plus to a minus. Then, after that, we write sine x, sine x. Let me just create space by erasing this part. Okay. It's cos x, sine x, sine x. Then cos, and sine. If it's good x, we are saying x times x minus y times y. X times x is just x squared minus y times y is what? Y squared. It simply means that cos x is cos squared x minus sine x again is sine squared x. Therefore, this is just a proof to show that cos squared x minus sine squared x is truly equals to cos 2x according to the identities. Thank you very much.